Dear students, I welcome to you all for this session on dynamic modeling. So, see the people, how people are changing their states, how the actors are interacting, collaborating with each other, and what type of activities are performed by these actors. So, what aspect to model in dynamic modeling? What are the states in life cycle of the actors? So the dynamic behavior of the actor is considered with respect to state transition, interaction, collaboration, and the activities performed by the actors. So what aspect to model? How does the group collaborate? How does the individual respond? So illustrative example, states in life. So you can consider birth as state 1, school life as state 2, service life as state 3, retirement life as state 4, and death as state 5. So when we are moving from the state S1, that is birth, to school life S2, the transition is there. This transition is measured in terms of event, action, and guard condition. And therefore, states S2 may perform various activities like admission, enrollment, attend lectures, study, examinations, and placement. Service life between initial state college graduate to final state retirement is entry level, associate, senior, executive. So between initial state, that is college graduate, and final state retirement, there are many states like entry level, associate, senior, executive. So, what is state transition diagram? A state transition diagram shows the life cycle of an object, what event it experiences, it transitions, and the states it is in between these events. It thus represents the single object and how its behavior causes it to change state. State transition diagram can be constructed for the software classes and use cases. Software classes, the STD of dynamic class shows the sequences of states that object of a class go through during its life cycle in response to external events and also its responses and actions in reaction to an event. Use cases STD of the use case depicts the overall system events and their sequence within a use case. So these state diagram are used to capture the behavior of software system. UML state machine diagrams can be used to model the behavior of a class, use case, a subsystem, a package, or even an entire system. It is also called a state chart or state transition diagram. So what are the application of state diagram? Like most UML diagrams, state diagrams have several uses. The main applications are as follows: depicting event-driven objects in a reactive system, illustrating use case scenarios in a business context, describing how object moves through various states within its lifetime. State diagram also shows the overall behavior of state machine or the behavior of related set of state machines. So, state. What is state? A state is a condition or situation in the life of an object during which it satisfies some conditions, performs some activity, or waits for some event at a moment in time between the events. State can have three components. In this notation, the first shows the state name, the second shows the state variable, and the third is the activity compartment where activity and events are listed. State may have activities which are functions that begin execution as soon as the state is entered and executing until completion or until the state is left. State is represented within the state by a do activity symbol. So a state is shown as rectangle with rounded corners and the state name inside the rectangle. Initial state, which indicates the default starting place for the state machine or substate. And initial state is represented as filled block black circle as shown in. This is the final state. Final state which indicates that the execution of the state machine or the enclosing state has been completed. So a final state is represented as a filled black circle surrounded by an unfilled circle. So here transition. Transition is a relationship between two states that indicate that when an event occurs, the object moves from the prior state to the subsequent state. For example, when the event of hook occurs, transition the phone from the idle to active state. So here initial state is shown, then state 1, its attributes are state 1 may have a transition 2. So between state 1 and state 2, transition is written and then this is a final state. This state 2 may have many states like S1 and S2. If such type of situation is there, then these are the nested states. Now what is event and action? An event is a significant or noteworthy occurrence. For example, a phone receiver is taken off the hook. An event occurs whenever information is exchanged between an object in the system and an outside agent, such as user, a sensor, or another task. The information values exchanged are parameters of the event. For example, the event password entered has a password value as a parameter. Anytime information is input to the system or output from the system due to which an event occurs. So here in this figure, state 1 is there, state 2 is there, and there is a transition from state 1 to state 2. So event and action act as an input and gives output as state 2. So events can be categorized as external event, internal event, and temporal event. External event is caused from an object outside the system boundary. Internal event caused by an object inside the system boundary, while temporal event is caused at a specific instance of time. Temporal event can be generated at a particular time, say after 20 minutes or when a particular condition is satisfied. For example, temperature is greater than 100 centigrade. Now, there are two special events, entry and exit. The action associated with an entry event is executed whenever a given state is entered through a transition. Exit, the action associated with the exit event is executed whenever the state is left through the transition. So here there are two notations, one for entry point, second for exit point. So in this entry point, the action is associated with an entry event, while in exit, the action is associated with the exit event. Transition action. What is transition action? A transition action is a transition that causes an action in a state to fire. A transition can cause an action to fire. In software, this may represent the invocation of a method of an object. Action is instantaneous operation associated with an event. Transition action take negligible time to complete. Transitions are labeled arrows connecting states. The operation event is attached to transition of the state. The notation for transition action is slash, and the name of the action following the event, that is event slash action. So transition action can cause an action to fire. In software, this may represent the invocation of a method of an object. While transition guard conditions. A guard is a logical condition that will return only true or false. A transition may also have conditional guard known as Boolean test. The transition is only taken if the test passes. A guarded transition occurs only if the guard resolves to true. Only one transition can be taken out of a given state. So the guards are mutually exclusive for any event. Guard condition can be shown in brackets following event name, that is event stroke action, and then you can specify the guard condition. So under the transition guard condition, a transition may also have a conditional guard, that is Boolean test. The transition only taken if the test passes. So in summary, you can say that the guard condition is a Boolean function of object values. Guard condition is valid over an interval of time. It can be used as guards on transitions. Guard condition is shown in brackets following the event name. So here state name 1 changes its state when event is fired under some action followed by any guard condition to state n, or you can say state name 2. The activity is method invoked by the state. Figure shows the state transition diagram for the dynamic class or use case. For example, when a water liquid state is heated, do activity, then it goes to vaporized state. And when water is cooled, that is do activity, it may go to solid state. And therefore, the state is represented by state name 1 with variables and do activity 1. Event is fired under some action, and action will take place under the guard condition, so that state 1 will change to state 2. Here initial state is shown, state is there, event trigger, some action will take place. So state 1 will go to state 2. State 2 will have self transition, it may be there, may not be there. Now again from state 2, event will be triggered, some action will take place, therefore state 2 will go to state 3, some activity will be done by state 3, again event can trigger, action can take place, state 3 will be changed to state 2, and then the final state. So you map this example with water cooling. Water is heated, it will go to vaporized state. It is cooled, it will go to solid state. If it is heated, again it will go to. So This is illustrative example. Suppose you are in idle state, your phone is off hook, that is event, stroke action will take place, that is play dial tone. If you are a valid subscriber, then phone will move to the active state. Again, if you will keep the phone on hook, it will go to idle state. So in this figure, you will see that the state is changed from idle to active. Up hook is the event, play dial tone is the action, and valid subscriber is the guard condition. And this light, this line indicates the transition from the idle state to active state. Again, second example, you can see idle state is there. You click the right button down, it will display the pop menu. Menu will be visible, and again, this state menu visible will have some event, that is cursor moved under the action highlighted menu item, and then visible menu will change to the idle one. When you will click right button up, it will erase the pop-up menu. Then state nested diagram. State diagrams can get complex. For better understanding and management, you can construct the nested state transition diagram. In nested state diagrams, a state in a state diagram can be expanded into a state diagram at another level. So you can consider it as a inheritance of transition. So in this figure, you will see state 1 is there and other state is there. So substate 1 is like a customer authentication and substate 2 is a transaction. So this is the notation for the nesting of state or for composite state. Here it is divided into two compartments. At the top level, you can give the name of the state, serving customer, and serving customer is divided into two states. This is start of the state, initial state. This is the end of the state. So composite state serving customer has two substates, namely customer authentication and transaction. So just we have seen STD for telephone and active state is nested in state transition diagram. So this is a STD for telephone and this is the nested state. You can, it is not visible. So you can see here telephone state is idle. When it is on up hook, it will play dial tone under the guard condition valid subscriber. Now active state is nested state, so it will start playing dial tone. You will dial the digits. So this is a recursion. You will dial the digit till the number is complete. So dialing will start. When the dialing of number is complete, you will be connected to the second party and then you will start talking. So in this way, the active state is divided into dial tone, dialing, connecting, talk, and if you will keep on hold and will keep continue on hold, there is a history state H. It will keep the history of the event. So state diagram will have continuous loop. Graph is a loop, or there may not be a definite start state. and not concerned about how the loop starts. So in continuous loop, if you will think about the telephone system, you will dial the tone, state is dial tone. There is no start state or initial state. Now telephone is on hook, it is in idle condition or in idle state, and if you will take it off hook and then it will go to the dial tone state, you dial the digit, so dial tone state will change to dialing. Here transition is dialing the digit, again you will keep the phone on the hook, it will go to the idle state. So in this figure you will see the continuous loop. There is no definite start state, and we are not concerned about how the loop starts or how the loop ends. Then there is other concept of one shot life cycle. One shot life cycle represents object with finite lives. The object enters in initial state on creation of object, and it enters final state to destroy the object. The initial state is represented by solid circle and final state is shown using bullseye. Object for which one shot life cycle state transition diagram is drawn have fixed life from start till end state. Now, in this figure, preparation, approval, approved, then state is scheduling for publication, then publishing, and then end. So, in one shot life cycle, there is a start state and there is end state. End state is the destruction. So, construction of state is there, destruction of the state is there. So constructor is there as well as destructor is there. So one shot life cycle represents objects with finite lives. Initial state entered on creation of object, entering final state destroys the object. So in this figure, initial state shown using solid circle and final state shown using bull's eye. This is second example of one shot life cycle. Start the game, white moves, black will also move, black moves. Now white moves, then black wins. This is the destructor state. Then stalemate will be there, transition will be there. For move, for black move, again stalemate transition will be there, and you can draw something and then white will win. Now we will study operations. Operations are attached to the states or transitions. Operations are performed in response to corresponding states or events. There are two types of operations, action and activity. So I said operations are attached to states or transitions. So action is an operation which is attached to transition, while operation is an activity which is attached to states. So operation, that is action, is instantaneous operation. It is associated with an event. Notation for action is slash and the name of action following the event. So action is a operation which used to take negligible time to complete, while activity is an operation that takes time to complete and is associated with a state. Activity include continuous or sequential operations, and it starts on entry and ends on exit. An operational behavior is do activity that is executed while being in state. The execution starts when the state is entered and stops either by itself or when the state is existed, whichever comes first. So activity takes some time to complete and act as a method into the dynamic class. So what is the difference between action and activity? Action is instantaneous operation and take negligible time to complete, while activity is an operation that takes time to complete. So see this example, state activities, login, do, this is the activity name. Whenever you will do login, activity is do display login prompt. Then from state login, there will be a transition to state password and then do get password. So do get password is a activity. Do display login prompt is a activity. Activity is a operation which used to take time for its completion. Now you can see this example, state transition diagram for the use case by items. So here waiting for sale, first you start the transition, it will go to the state waiting for sale, enter item, you can enter the items, then end sale, entering item state will be changed to waiting for payment, and you can make the payment, so that waiting for payment state will go waiting for sale. Now there are some other notations about decision points and synchronization. The decision points give decision paths in state chart diagram. Figure shows that state A can transit to state B, C, or D based on decisions made at the decision point, shown as a diamond shaped notation. Decision point is represented by diamond, and the states are connected as a state A, state B, state C, and state D. The bar shows in second figure, the bar shows concurrent state, a thick bar. The first bar, this is start, this is a bar, thick bar with one transition. Entering it shows the beginning of synchronization period. Two or more transition can exist, the synchronization bar on the other side. So here synchronization bars are synchronized, they are paired. So another bar with two or more transition entering it and only one transition leaving it must be paired with the first. The first bar, this first bar is called the splitting up control, where the second bar is called synchronization bar, because the output of state A and output of state B both are synchronized, and therefore second bar is called as synchronization bar. Parallel states and synchronization. So the state transition diagram of object or use case may include more than one states that executes in parallel. The presence of parallel state machine indicates that the instance of a class or use case engages in different independent activities which executes in parallel. If there are different CPUs like CUDA machine, then different tasks can execute in parallel. If any program, each process says state name instead of n processes like S1, S2, S3, Sn can be executed concurrently. Then this figure illustrates the parallel state in state machine. The dashed line is included to emphasize the parallelism. So state 0, that is H0. So H0 is a starting point. This is a state. And from this state, a thick bar with one transition enters the beginning of synchronization period. Now, this state is a composite state and is divided into state S1 and state S2. S1 and S2 are divided, or compartmentalization of these two states is done by this dashed line which indicate the parallelism. So S1 activity and S2 activity will be conducted in parallel, and their results will go to the second bar, which is a synchronization bar, and then the next state will be there. So such type of situation may happen in parallel processing. Now, homework case studies. So here roadmap is a state machine for the bounded buffer problem, or state transition diagram for the whole system. I said that you can construct the state transition diagram for the class as well as for the use case. So I will illustrate the bank ATM case study where the use case ATM card verification and transition will be considered for the construction of state transition diagram. Secondly, we have studied Dr. Babasaheb Ambedkar Library VJTI case study. So this case study will be considered to construct the STD for the dynamic class. So we will study how to construct state transition diagram for the dynamic class and how to construct state transition diagram for the use case. Then I may give some think tank questions that you have to do at house. You have to construct the STD for testing, or you have to deal with order of execution of use case on the basis of precondition and post condition, and STD for student life. So static model, stack. Consider the stack. In stack class, we have shown the activities push, pop, and size. So this is a static model of the class. Now, state machine for the stack. You consider the initial state. Initial state, the stack is empty. Now, you can insert the elements into the stack. So what is the guard condition? for inserting the elements into the stack. The guard condition is size should be less than max minus 1. Due to this insertion of the elements into the stack, the empty state of the stack will change to partial state of the stack. Now in this partial state, you can insert the elements till size is less than max minus 1. And due to this transition, the partial state will change to the full state of the stack. Now you can fetch the elements from the full state of the stack. So when you will fetch, you can fetch the elements till size is greater than 1. This is the guard condition. So due to this guard condition, size is greater than 1, the state of the stack which is full will change to partial state. Now when the stack is in full state and you are fetching the elements from the stack, and if stack size is equal to 1, then the state, that is full state of the stack, will go to the empty state. So full state will have a transition to the empty state. You can handle the error conditions. So here fetch signal error condition is added. Here also insert signal error condition is added. So you can add the error handling mechanism into the state transition diagram. So here the size gives the number of items currently in the buffer, whereas max is the capacity of the buffer in terms of number of items. Initially, the state machine enters the empty state and insert message in the empty state, takes the object into either full or partial state depending on which guard condition evaluates to true. A guard for message is specified in square braces adjacent to the message. So this square brace is nothing but the guard condition. So in this machine, a fetch event received in state empty or an insert event received in state full is lost. Now you can modify this state transition diagram. How you will modify? The stack is changed from empty state to full state, from full state to partial, from empty state to partial, or from partial state to full, or from partial state to empty state. You can easily add the activities like push, pop, stack overflow, stack underflow, or any transaction. Do activity is concerned with the state. If stack is empty, which activity you will perform? Push element. If stack is full, you can pop the elements. So do pop activity will be added into the state full. Overflow. If stack is full and if you will perform the activity do overflow, then there will be the overflow. Underflow. Now if stack is empty and again you will try to take out the elements from the empty stack, the do activity will be underflow. And you can perform some other transactions on the elements, whether you would like to add two elements, or you have to perform some other operations like conversion of prefix to postfix and so on. So here trace every incoming message to an object as transition. Object changes its state in response to a member function invoked on it. After the state is changed, the response to subsequent invocation depends on new state. Now we will deal with the case study ATM system communication. So this is a representative block diagram for ATM system communication. Screen, keyboard, card readers are there. ATM system software is loaded into the machine. This machine is attached to the bank computer, which will validate your ATM card. And then after validation, you may deal with your account database. So STD for ATM. So state machine bank ATM, you start the transaction. So this is start state, machine is up. So turn on, action will be start up. So self test will be there. Now this self test will have a transition to idle state. Then if it is in idle state, transition will be service for the maintenance state. If there is any failure, ATM is out of service state. Again, you can provide the service for the maintenance. Here, when the machine is out of service, you can turn off or shut down so that machine will go to the off state. Now from self test, you will move to idle state, and from the idle state of the machine, you can insert the card into the machine. While inserting the card into the machine can serve the customer. So this is a composite state that we have studied previously, serving customer. So entry and exit, these 2 points are there in this composite state. Entry is shown by this start state and exit is shown by this bull eye like notation. So read card. So by reading the card, customer authentication will be done. Then you can select the transition, and then transition will take place, and after that you can eject the card. Here user identification by ATM card. So how this use case is used to construct the state transition diagram. So here one use case, that is user identification by ATM card, is considered for the construction of state transition diagram. This is a start state, card swept, waiting for pin. You can enter the pin, pin verification will be done, pin authentication will be done, and user will be identified. So start state is there, end state is there. Now waiting for pin state is converted to pin verification. If pin is rejected, pin verification state will change to waiting for pin. Again you will enter the pin. So this is a loop between waiting for pin and pin verification. So customer is authenticated by PIN. But in those days, some modifications are made into the system, and while entering the PIN number, again the user is authenticated by the OTP. You will receive the OTP on your mobile number. So state transition diagram for it is begin entering the OTP. You will obtain this OTP from your mobile number, and you will enter the OTP. OTP validation is true. Then user will be authenticated, and then termination. If OTP verification is false, again you have to enter the OTP. So in this way, the user authentication in ATM system is done with the help of PIN and OTP. So we have studied the Dr. Babasaheb Ambedkar Library VJTI, and statement of the problem is known to you. We will construct the use case diagram. So in the previous lecture of the use case diagram, we have considered this case study. Today, we may not deal with the class diagram, but this is the class diagram where member record, book, librarian, transaction, bill, and other classes are there. Now, for this case study, we will consider the book class. I said that we can illustrate the dynamic class behavior from the class diagram. So here, from the class diagram, you can identify the dynamic classes, and for each and every dynamic class, you can construct the state transition diagram. Here, an object of book take three different states in its lifetime. That is available state, issued state, unavailable state. Now, book is unavailable. So what is the do activity? Do wait for book to be returned. Now, book will change from unavailable state to available state. So when the return book and user finish reading, action will be pay fine if any, so that book is available. Now here start state is there. Book added to library, so book status is updated. So this is the event. Book added to library is a event. This is slash. Action is what? Book status is updated, so that book is available and you can perform the do search book activity. Now from the available state, you can move to unavailable state. Request for book issue. This is the event. What will be the action? User denied book. User denied book is action. Why? Because book is unavailable. Now, if you are at available state and if you are searching the book, this is a transition. So available state will be changed to the issued state of the book. So this is a transition. Issue book under the guard condition, copy of the book available, stroke, action will take place. Decrement count of available copies. Book is issued. So entry point is what? Assigning book to the user, and Do activity is what? When the book is issued, user reads the book or user take the book to the home. In this way, class book is a dynamic class, and this dynamic class will have three states in its lifetime. User is also a dynamic class, and this dynamic class may take following step: guest, register, idle, logged in, searching, issued book, returning book. So this is a user dynamic class whose object takes the following state: guest, registered, idle state, and logged in state. This is nested state for the class user. System state transition diagram for the school life of a student. This is start state. Student will do the enrollment. Term is started. Being taught is the state. Student is dropped. If seminar size is greater than 0, again being taught. After teaching is over, classes end, and you have to appear for final exams, and teaching will be closed. This is the end of the operation. Exit. So this is a one shot life cycle diagram for the school life of student. Now think tank questions. Draw the detail whose testing state transition diagram. Give your opinion about the execution of the use cases of system using precondition and postcondition of use case diagram. In library system, member of librarian actor can act as a primary actor. What is your opinion? Justify. Can you use state transition diagram for construction of activity diagram? So this is a third think tank questions. Think on these questions and try to obtain the answers. Thanks to you all.